Bismillah. Today we are going to discuss a very important problem related to Rhmkurff coil. So what is Rhmkurff coil? Rhmkurff coil, as we can see, is a device that uses a low DC voltage to output an induced electromotive force uh, which is very large to do certain function, uh, like to operate high voltage devices. So what does a Rhmkurff coil consist of? What does Rhmkurff coil consist of? It consists of a primary coil connected to a DC battery of low number of turns. A primary coil that consists of low number of turns. Secondary coil that is connected to the gap or the extreme we are going to operate. And of course, the secondary coil has very large number of turns. And here there is a circuit breaker which helped in closed and closing and opening the circuit. In a way or in another, we have nothing to do with this complex components here. We have to deal with the primary here and the secondary circuit in a simple way. And let's start reading the problem. The primary coil of Rhmkurff coil of 200 turns, so NB equal 200, and it is wound around an iron core, and here the iron core is common between the primary and the secondary. I mean they both are wound around a common cross section area. Diameter 3.5 centimeter. I make use of the diameter to get the radius, and we have to convert here. Its permeability coefficient equals 0.002 Weber per amp meter. Okay. If the current flowing through the primary coil is 4 amp, and here is the current, and of course if this current is cut off, the operation will take place during the cut off. Calculate the induced EMF in the secondary coil of a very large number of turns, 10 power 5 turns. Also calculate the mutual induction. So let's analyze the givens to output our answer. The inputs here allow us to write three physical equations. What are they? The secondary electromotive force equal N2 rate of flux here is a product of the field, the primary field times the secondary cross section area, which is common cross section as I have mentioned. So we have to calculate the field of the current here first of all. So the field here of the primary current is given from the relation P1 equal mu N1 I1 divided by L, and here I use of course the number of the primary coil, which is 200, to calculate the acting field, and it is equal 16 Tesla. It is equal 16 Tesla. So I have to calculate the interacting cross-section area with that field by using pi r square. Using your calculator, you will output as an answer this value as an answer. And we have to calculate, we have to substitute here in the relation to get a very high induced electromotive force. This is because the very large number of turns that interacts with the collapsing field of the primary coil. And here we have a very high voltage, which is a pulses voltage that can operate certain devices such as cathode ray tube or the internal combustion engine in the car has to be operated using that device. Of course, I have to keep the mutual induction at a side by using the method of Henry to keep it to get it as 385 Henry, and we need to see here that it is a high value, and that's all for now. Thanks for watching.